Young people, here we are again with more bonding, ionic bonding. We're adding polyatomic ions here. Pretty simple thing if we understand the other bonding, so make sure that you understand all of that. So topics to understand, we're applying the same methods that we used before to the ternary compounds. We're trying to write correct formulas for ternary ionic bonds and correctly naming them even with D block metals. So here we are, dot structure method. This is problem. This is the problem right here. The dot structure method does not work because we do not know the dot structure for the polyatomic ions, so you may not use this one. It will not work for anything but S&P block representative elements. So I do have to tell you, if you've used the dot structure method in the past, you're going to have to find a new method. Now the next method is the one that I'd probably look for, and that's the visual plus and minus. It works with every single combination. So let's talk about Cu plus plus, okay? And let's pull a polyatomic ion together. We're gonna have PO4 minus minus minus. So we know for every positive or every electron loss we need to be gained. For every electron loss we need to be gained, but we have more electrons that need to be gained. So we need another Cu. So here's a Cu plus to a minus. But now we have more to be lost, so we need more PO4. Notice my O is big. It's not a little o because that would be polonium, not oxygen. That's phosphorus and oxygen. So loss to a gain, or a gain to a loss, or loss to a gain, yep. Now we need more copper. There we go. There we go. And now we see that everything is good. So now we have Cu3, and we have more than one of the groups. So we have to remember, when we have more than one of a group, we are going to put that group into parentheses, just like we would in math. Okay, we're going to do that just like we would in math. Sorry, I jacked that up. My finger's not working very well today. So PO4, okay, I'm going to put that in parentheses. How many do I have? I have 1, 2, so I'm going to put a 2 on the outside. Now, because the copper is a D block metal and it changes charge, I have to make sure that I talk about that. So this would be called copper, and because it's a 2 plus charge, it'd be called copper 2. And then the PO4 group, according to your polyatomic ion sheet that you have in class that you can use, is called a phosphate. Now, once again, you have another name for copper that's called cupric. So you could substitute cupric for copper 2 as well. So you see how the visual plus and minus method works. This will work for every single combination that you'll ever use. And if you're visual, I would choose this since the dot structures fell apart. Okay, least common multiple method. So this works for every possible combination as well. So here we go. We have the Cu2 plus. We have the PO4. Be careful that 4 is with the O. 3 minus. Okay, what number is the least common multiple between 2 and 3? That means the smallest number that both 2 and 3 will go into evenly. And the answer is 6. That means I need 6 lost and I need 6 gained. So what do I need to do to get 2 to be 6? Okay, I need to multiply by 3. What do I need to get 3 to be 6? I need to multiply by 2. So that means I have Cu3. PO4, remember, has to be in parentheses again because it's a group. I've got to say all of the group 2. And what that means is I have 2 phosphorus and 8 oxygen. Okay? And again, we already know the name of this. This is copper 2 phosphide or cupric phosphate. Okay? Last method. Last method is the switcheroo method. This method falls apart again. Remember, if you don't understand the exceptions, don't use it. So here we have the Cu2 plus. We have the PO4, remember the 4 belongs to the O, 3 minus, and what we're saying, oops, that's not a minus. Okay, let's try this again. Erase, all right, minus, okay. So the 2 becomes the number of the phosphate I need, the 3 becomes the number of copper I need, and I get Cu3 PO4 2. And again, cupric phosphate or copper 2 phosphate would work for this. So you can see polyatomic ions are no different. We treat them the same, except that they're groups, so we have to keep those groups together. We have to make sure that we consider them as a whole. We can't drop numbers. We can't change numbers because changing numbers changes what it is. So be really careful with that. Make sure when you have more than one of a group, you use parentheses. If you only have one of a group, no parentheses are needed. So make sure that you're looking at that. All right, thank you very much.